Okay, so we have three laws of exponents problems here. The first one dealing with the product, and here we have a power to a fractional exponent, and here we have the quotient, right, of two equal bases with different exponents. Let's start with the product over here. The idea is that we have 2 to the 5th, which is 2 times 2 times 2 times 2 times 2, right, 5 2's, and we're multiplying that by 2 to the negative second, which is essentially 1/2 times 1/2, or 1 over 4, or 1 over 2 squared, right? That would also be equivalent. So we can regroup these. I'm going to say let's multiply this 2 and this half, and then this 2 with this half, those would cancel out to 1 and 1, right? 2 times a half is just 1, and we're left with the answer, which is 2 times 2 times 2 right here. We're simplifying, that's just 2 to the 3rd. A shortcut, of course, would be to add these exponents, because 5 plus negative 2 is just 3, which is our exponent right here. So in general, of course, when we're multiplying two equal bases, right, here the base was 2 and 2, so the base is equal, and we have different exponents. What can we do? Well, in general, we can just add the exponents as a shortcut. So it's x to the a plus b, right? That's our general structure there. Let's jump here to the last problem. You can imagine that when we're multiplying, if we're adding exponents, when we divide, since division is opposite, the general shortcut is to subtract the exponents. So when we're multiplying, we add the exponents. When we divide, we subtract the exponents, as long as the base is equal. And this problem is slightly tricky, though, because here, right, if you think about what's happening, 3 times 3, 5 times, over 3 times 3, 7 times, right? Altogether 7 times. So here, what's going to happen is if we group, right, 3 over 3 and 3 over 3, these each cancel out. So in a sense, that's why we subtract, right? We subtract out the equal pairs, right? There are 5 equal 3's in numerator and denominator, which should leave us, oops, I made a mistake here, 2 3's left over, right? That's 7 3's. So you could say, oh, that's equal to 1 over 3 squared. Or you could say that's equal to 3 to the negative 2. Or you could say that's 1 over 9. Now, depending on the format, they might want you to avoid negative exponents. If that's the case, you would then choose one of these formats right there. If they want you to leave it in exponential form, you would choose this numerator, this fraction right here. If they don't mind, you could choose then 1/9. These are all equivalent, but usually they want us to avoid negative exponents. And the last one here, negative 32 to the 3/5 power. It seems a little intimidating at first, but if we kind of split this fraction up, we can think of it as 3 times 1/5, because that is 3/5, or we could reverse that and think of this as 1/5 times 3. Now, what does that mean in either case? Well, when you have the 1/5 power, you're finding the 5th root. You're finding a number times itself 5 times, that gives you negative 32. So I don't want to cube 32 first, right? So I don't want to choose this one because I don't feel like doing that first. Instead, I'm going to find the 5th root of negative 32 first, and then raise it to the 3rd power. I find that to be easier. So what is the 5th root of negative 32? Well, that's just equal to negative 2, right? Because negative 2, if you can imagine, times negative 2 times negative 2 times negative 2 times negative 2, well, this will be a negative product that equals 32. So that is the 5th root of negative 32. We're raising that to the 3rd power, which is negative 8, right? Because negative 2 times negative 2 is positive 4, times negative 2 is negative 8. All right, hope this helped.